All right, everyone. First, before we go anywhere, let's talk about the homework. All right, so the limit as h approaches 0, plugging it in right away. Not only are we going to see division by 0, but we're going to have 0 over 0. So we expand the binomial. Combine like terms. Reduce by h. And then set h, and then h goes to 0. We have 2x. Okay. So let's take a look at the reason why we do this. So going back to the beginnings of calculus, there was a question about how do you find the equation of a tangent line. And so if I wanted to find the equation of a tangent line, say at a certain point, let's call it x. The idea was that we could approximate that tangent line because that tangent line is, only touching at one point. We could approximate this tangent line by finding another point down the road. Let's call it x plus some distance, where that distance is a change in x. And if we did that and used a point and used these 2 points, I could find kind of a lousy approximation to the tangent line. But if we were to go ahead and make it a little bit smaller distance, you might see that these 2 points would come close as they got closer and closer to the real tangent line. And so what they did was they said, okay, this point is the point x, f of x. And this point is the point x plus delta x, f of x plus delta x. And then to find the equation of the line, we use point slope. But in order to do that, we have to find slope. So to find the slope, it's the change in y value all over the change in x. That's slope. Well, the change in the y values is all over the change in the x values. And the change in the x values, as you can see, is just delta x, which is what we saw already down here. So this is the equation of an approximate slope of a tangent line. And what I've done is I've put this together for your viewing pleasure. Now I've used the variable h to represent delta x, the change in, the small change in. I'm trying to find the slope of the tangent line at the point x equals 1. And just so that I actually have it, now this line, and I'm just going to go ahead and clean this up a little bit. Go ahead and clean this up a little bit. So this line, which I'll make blue, is my lousy approximation to this perfect red dotted line. But as I make my h smaller and smaller and smaller, you can see that it gets closer and closer and closer to the actual honest to God tangent line. But right here, it doesn't exist. Why? See if anybody else. Why do I get, why does the line not exist? Okay, so if they are both the same point, then how can you tell me what the slope is between 2 points if they're the same point? That's a good point. But you can see as we have large h's, it gets to be a rather crappy approximation. But for small h's, it's pretty good. Not that bad, right? Okay. So what we want to do is get this delta x as small as we can. And to do that, what do we do to make something smaller or smaller and smaller and smaller? What mathematical process have we been working on for the last 2 weeks? We take the limit as delta x approaches 0 of x plus delta x minus f of x all over delta x. And as this gets closer and closer and closer to 0, we come up with a new function, which we're going to call f prime of x. And this gives the slope at a given point. This is also, by the way, this is called this is the fundamental theorem of calculus. Differential calculus. This is what's called the derivative. The derivative is a function that gives the slope of the tangent line at a given point. And this is its formula. Now, I know that some of you are just going to go off to Khan Academy and YouTube and find shortcuts and ways of doing all of this work. I understand that. So I might as well just give you the curriculum and say, go to YouTube and Khan Academy. And if that's the case, then that's fine. We'll just give you your IB diploma now. But for the rest of us that are actually trying to learn, we're going to actually go through the process of doing the work. Okay, so let's try and do the work. Let's do math in math class. What do you say? You know, that would be fun. Let's try that. So if I give you your function as x cubed, I'd like you to find the derivative. So we do the following, and we do all of the following. Some people are in for a rude awakening. And you can either use delta x or h, I don't care. Some people are in here for a rude awakening when they're in person and they don't have Khan Academy or Photomath or any of these things to do their work in class. It's going to be a fun year next year. Yeah. You know, I would much rather if people said to me, Ronco, I don't get it, than people saying, hey, Ronco, this is not really my work, but I'm going to go ahead and submit it anyway. Why do I keep mixing my variables? Delta x, I'll just live with delta x. So this is the limit delta x approaches 0. And when we expand that, because we all remember how to do our binomial expansions, squared. Snap. So you know that you're doing this correctly if at some point down the road you get rid of the delta x that's in your denominator. So the x and the minus 3x, the x cubed and the minus x cubed go away. And I have 3x squared delta x plus 3x delta x squared plus delta x cubed all over delta x. So now that everybody in my numerator has a delta x, I can go ahead and factor it out and cancel. and I have 3x squared plus 3x delta x plus delta x squared. Now, when delta x goes to 0, this term and this term both go to 0. And I am left with 3x squared. So if I said to you, similar problem, find the equation of the tangent line of y equals x cubed at x equals 4. Let's make it 2. You would, in order to do this, you need a point and a slope. So you need a point and you need a slope. The point comes from the fact that you have x equals 2. So that's 2 and 2 cubed. So 2 and 8. That's the point that we're going to use. That's my function, x cubed. The slope comes from the derivative. And I'm looking for it at 2. So this is 3 times 2 squared, or 12. This is your slope. Think about it as the m in y equals mx plus b. So now I have point slope formula. Y minus y1 is equal to m x minus x1. So y minus 8, 12, x minus 2. So y is equal to 12x minus 24 plus 8. Y is equal to 12x minus 16. All right. Does everyone have that copied? All right. So now strike that. You will find the slope, just not right away. Yeah. Let's do. So take this and plug it into the formula. And I'm just going to use H because it's, I know I'm lazy. It's easier to write. Um, take this. This is your f of x. Plug in x plus h. There's your function right away. Expand out this binomial, what's going to be in here, simplify, and get your derivative. When you get your derivative, put your derivative in the private chat before you go ahead and find me the equation of the tangent line. All right, so let's do this. All right, so make sure that you wrote that. Okay. So I've expanded the polynomial. Now I'm going to distribute and combine like terms. So 4x squared cancels with negative 4x squared. So I have 8xh plus 4h squared. The plus 3 and the minus 3 cancel out. And now I have that. And now when h goes to 0, this goes to 0, and you have 8x. So now this is my new derivative. This is the f prime. So the slope of the tangent line is f prime of -1, or 8 times -1, or -8. And now you need to use point slope. So finding the point is to find the function's value. So that's 4 times -1 squared plus 3. 4 plus 3, or 7. So I have -1, 7. So this is my point. And this is my slope. So let's all redeem ourselves by finding the equation of the tangent line using the point and the slope. So I don't have to reach through the internet and kill you. So point slope formula, y minus y1 is mx minus x1. So I have my slope, I have my points. Y minus 7 is equal to -8, x plus 1. So y is equal to -8, x minus 8 plus 7, y is equal to negative 8x minus 1. Okay. I'm nervous about asking the next question, but we're going to try it anyway. Do you want to try it? Good. I'm so glad everyone unanimously just screamed yay and yes. Oh, that's wonderful. It was resounding and lovely to hear. Get to it. When h goes to 0, I have and you're done. And to plug it in at 2, gives you that. Okay. All right. Okay. The last one. Let's try this. Let's try a low ball here. Oh, let's not make it too bad. Find f prime. So find the slope of the tangent line. At x equals 3. All right, so there are lots of little errors I think I saw some people make. So I have the limit as h approaches 0 of x plus h squared plus x plus h plus 5 minus x squared plus x plus 5 all over h. So x squared plus 2xh plus h squared plus x plus h plus 5 minus x squared minus x minus 5 all over h. So the x squareds cancel, the x and x cancel, and the 5 and the 5 cancel. And I have 2xh plus h squared plus h all over h as h goes to 0, which is the limit of h approaching 0 of 2x plus h plus 1. And as h goes to 0, you get 2x plus 1. Plugging in 3, I get 2 times 3 plus 1, which is 7. Okay.
Good afternoon, Great High School. We have a couple bus changes today.
All right, everyone pay attention so you catch the right bus on your way home.
I get students who ride bus 300, 99 today, and that will be the students who typically ride bus 231, will ride bus 438. People who normally will ride bus 438 today, that will be finally, students riding bus, students typically ride bus 746, will ride bus 3. Again, students typically ride 746. will ride bus 354. Thank you. That's all the bus changes today.
All right. But trust me, you will have metric god awful amounts of homework on this unit. But I'm only going to give you one today, just so that you don't completely forget how to do anything. I want the derivative of x plus 1 all over x plus 2. And then I want this. Yeah, it's the derivative of the derivative. Oh, wait, strike that. I want the second derivative. So this is the function.
All we need to know.
2 homework assignments between tonight and tomorrow. Take pictures, show me your work. And another thing, if you're sending me your homework at like 10 o'clock in the morning, that means that you're in class and you're doing your math homework when you're supposed to be in like French or some other thing. So like show your teachers some respect and don't make me realize that you're not paying attention to your other teachers. Try and get your homework in tonight. That'd be nice. Okay. Merry Christmas, Happy New Year. Go play in the snow.
Have a good one.